What's up, guys? Good morning. We're going to continue with our graphing of quadratic functions with section 8.5, which is using intercept form. So we're graphing in a new type of form here. So core concept. So you'll notice that intercept form is like the factored form of a quadratic equation. So this is what intercept form is looking like. Your x-intercepts are going to be your p and your q values. So it's sort of like the opposite signs that we've seen here of your values that are in this form right here. Those will be what your x-intercepts are. So where it crosses the x-axis, this point and this point here. Now we have a new formula for your axis of symmetry. Your axis of symmetry is x equals p plus q divided by 2. And the reason it's dividing by 2 is you're almost like you're taking the average of those points to get this middle point and that middle line, which is your axis of symmetry. Similar stuff dealing with a. When a is greater than 0, your graph is going to open up. And when a is less than 0, your graph is going to open down, which you should know by now. So let's look at an example here. We've got graph f of x equals negative, and then in parentheses, x plus 1 times x minus 5. So we want to start by identifying our x-intercepts. And we know that they're going to come from these points right here, but it's going to be the opposite signs. So our first x-intercept is going to be negative 1, 0. And then our second x-intercept is going to be at positive 5, 0. So let's go ahead and plot those points. Now let's find our axis of symmetry, which is going to help us find our vertex as well. So I know my axis of symmetry, x is equal to p plus q divided by 2. So here's my value of p right here. And here's my value of q. So to find what my axis of symmetry is, it's going to be x equals negative 1 plus 5 divided by 2. So x is equal to 4 divided by 2, which is equal to 2. So x equals 2 is my axis of symmetry. And you can kind of figure that out by just looking at what point is in the middle of these 2 points here. So we know that there is my axis of symmetry, that imaginary line. Now I haven't actually figured out what my value of my y point is, or where my vertex point is, because I only have an x. So in order to find the vertex now, I'm going to have to take that x value and I'm going to have to plug it into my equation. Now remember, f of x is like the same thing as y equals. So I know that y equals negative, and now let's plug in our point here, our value of 2. So 2 plus 1, and then let's plug in that same x value again, times 2 minus 5. So what does y equal? Y equals negative 3 times negative 3. So y is equal to positive 9. So I know my vertex is going to be at the point 2, 9. So this is off the graph a little bit, but it's going to be up here. Now I could go ahead and I could draw in my parabola. Domain, whoops, like we've seen before. Whoops. So our domain is going to be all real numbers. And your range is going to be y is less than or equal to 9. Any questions? All right, let's go. All right, let's look at our next example. So we've got graphing 2x squared minus 8, and they want us to graph it in intercept form. Now you might be able to graph it in another type of form, but we're going to graph this in intercept form. So first thing I have to do is I have to factor out that 2. So when I factor out that greatest common factor, that 2, I'm going to be left with times x squared minus 4. So I'm going to change this to y equals. Now this can be factored. So y is equal to 2, this is the difference of squares, plus 2 minus 2. So this is my factored form, which I'm now going to have to graph. So let's graph that. Okay, I know my intercepts. They're going to be the opposite of these values here. So I'm going to have an intercept at negative 2, comma 0, and then an intercept at 2, comma 0. So let's graph those. Now let's find our axis of symmetry. That's equal to P, negative 2, plus Q, 2, divided by 2. So it ends up being 0 over 2, which is just 0. So I know my axis of symmetry is going to be at 0, which makes sense because it splits those 2 points in half. Now, let's find the y value here. So I have my x value of 0. I'm going to plug that in. I'm going to plug it in my original equation, so it'll make my life easier. So y equals 2 times 0 squared minus 8. So y is equal to 0 minus 8, or negative 8. So I know my vertex is going to be at the point 0, comma, negative 8. So let's go down there. 1, 2, 3, 4, 5, 6, 7, 8. Let's draw on our graph. There we go. Domain, like every parabola, I'll write up here, is all real numbers. Your range is y is greater than or equal to negative 8. Let's keep going. So we've got 2 examples here. I think you can go ahead and you can be able to do these. If you want to try them on your own, you can try them on your own. Remember, you can also always be using Desmos to help you with all these graphing problems, in addition to what we're doing. But make sure you know how to identify the vertex, the axis of symmetry, and the x-intercepts. Another one, this would be a difference of squares one, like we did before. You'd have to start by factoring out that 4, and then go from there. Let's look here. Find the zeros. Zeros are just another word for the x-intercepts. So when you see the words x-intercepts, or zeros, or roots, or solutions, it's all the same thing. So the zeros of this function are going to be the opposite of these 2 signs right here. So x equals 1 and x equals negative 2. So your x-intercepts would be at 1, comma 0 and negative 2, comma 0. So don't get confused by the term zeros. It's just basically you're solving for x. So for any factor x minus n is a 0, like we just talked about, of the function defined by the polynomial. And you should know this already. So here we say find the zeros, okay, of the function. So let's look at, we're going to do b first, and we're going to look at that one. So we have x minus 1. Now here, I have to factor this first, and this is the difference of squares. Remember the thing that we've seen lots of times now, the difference of squares. So this is going to be x minus 1, and I have to factor this to x plus 4 and x minus 4. And I've got this h of x is equal to this. So now when I'm asked to find the zeros, it's really like you're setting each of these things equal to 0. So like if I set x minus 1 equal to 0, I'm going to get x equal to 1, and that's one of my zeros. If I set x plus 4 equal to 0, subtract the 4, and you get x equals negative 4. That's another one of your zeros. And then on this one, I would add 4, and we get x equals 4. That's another one of your zeros. As points, these would be 1, comma 0, negative 4, comma 0, and 4, comma 0. Let's look at this one. Now, what I would start on this one is I know I can take a negative 2 out of all these, which would make my life a lot easier. Always look for that greatest common factor. Now I have x squared minus, oh, I should say plus 5x plus 6. Now I can factor this. Negative 2 times x plus 2 times x plus 3. Because remember, back to factoring, has to multiply to this and add to this. So what are my zeros here? Set this equal to 0. Set this equal to 0. You're going to get x equal to negative 2. That's one of them. And x equal to negative 3. So finding the zeros is just another way to say solve for x. Okay, find the solution. Again, you guys can go through these. Just remember when you see something like this, difference of squares, here, factor out that GCF. Last question here says use the zeros to graph x squared minus 2x minus 3. So let's start by factoring this because we want to graph it in factored form. So I'm going to find something that's going to multiply to negative 3 and add to negative 2. So hopefully you're thinking x minus 3 and x plus 1. I'm going to change this to y equals. So let's find our x-intercepts. It's just the opposite of those values there. So I've got x is equal to 3 and x is equal to negative 1, or it's the points 3, 0 and negative 1, 0. So let's plot those. Negative 1, 0 and 3, 0. Let's find the axis of symmetry and the vertex. So I know x is equal to 3 plus negative 1 over 2. So x is equal to 2 over 2, or x is equal to 1. So I've got my axis of symmetry going through 1. Let's find the value of the vertex. Now I could take this 1 and I could just plug it into here and here, into my original, or I could plug it into my new one over here. Doesn't matter. I'm going to do it in our original. Y equals 1 squared minus 2 times 1, minus 3. So y equals 1 minus 2 minus 3. So y is equal to negative 4. So I know my vertex is at 1 comma negative 4. So I'm going to plot that point as well. 1 comma 1, 2, 3, negative 4. And I could draw my graph in. Now notice domain here, all real numbers. Range would be y is greater than or equal to negative 4. All right, so that's how we can use the zeros to